Hello and welcome back. So let's continue with this series of tutorials. So in previous video we talked about the calculator. We already have seen that in particular when computing forces, but just to show you specifically how to compute coordinates, and operations with the calculator and so on, and play a little bit with threshold and clips and so on. So as you go to filters first, to show you something, recall documentation, and here you have this one Paraview Python documentation, okay? And here, if you go here, modules, available reader sources, right? Here you have the documentation for pretty much every function implemented in OpenFOAM. So if you want to know what they do here, you can come here. So in particular, I know the calculator, these are the simple calculators. It can take these functions, explain you a little bit. Then you have a programmable calculator with Python, but that basically you can use anything that you have in Python and so on. So you're invited here. It's very well documented and there is a lot, believe me. So every single stuff that you have there, and if you don't know what it's doing, just go there and you will have a brief explanation. You can always download the source code and read it. But okay, sorry, I digress a little bit. So if I go here and let me go search, I know that there is a filter called coordinates. So let's use this one. So you click here, remember that you can hover on that and then you have the tooltip. Then also with all these options here, you hover and then you have the tooltip, okay, so you want to know to get more information. So see here that you have a pinpoint locations and cell centers. You can get that information. I want everything. Okay, to get the coordinates, I want to have it computing in OpenFOAM, in Paraview, sorry, but from the solver, in this case, we're using OpenFOAM. Those coordinates will also have it from the mesh. So I will show you how to get them now because they are not exposed by default. Apply, and let me hide the aircraft there, and there you go. So we have this, and here you can access now point locations will be the cells, the nodes, and then the cell centers. You have it there. So it's up to you. And I want to point out that here you have magnitude, and then you can access is a vector X, Y, and Z coordinates. Okay, so what I was telling previously that you can get those coordinates. So if I use now cell center and I can say, let me clip everything below coordinate 0. Okay, so I know that's threshold, and this is a plane that you can put it there. Okay, so this is CCPC, but what I wanted to do threshold in this one, so I want to use cell centers. You can select what you want, X, and I want everything above 0, and there you go. Okay, so if I choose there, cell centers you have there, you can start to filter that. And remember that you can apply another one there. So let me put it here. So now I apply an slicing. You have it there, and not necessarily needs to be in that direction. And there you can do whatever you want in that. So you can always merge and combine them. So you can do very complex stuff here. So as you can see, very, very, very powerful, and you have all these options, so kind of hidden options. And if you want also, you can go from point locations and apply the same. So you have the cell centers and the node coordinates. So that is that filter, and let me hide it here. And what I wanted to show you that this is using the filter in Paraview. How do you get the coordinate from OpenFOAM? Because they are not exposed. You can go to the calculator, and just to remind you, this is the basic calculator. And as you go into documentation, you have instructions, all the functions and so on. Here you can access that and see here that you already have point and cell data. It's up to you, and you can get here your coordinates X, Y, and Z. So this corresponds to the file, the mesh information. So you go, and I will call it CX, apply, and to show you cell data, you have this. The cell center information is not safe. Okay, Now you can compute it in Paraview, but from the solver is not safe, but you have the option for those who knows Paraview that you can get that. Okay, so let me get all CY. Will be this one. Okay, sorry, this will be okay. Error, CY. CZ. Raise there, put it there, and there you go. So now I should have, oh, okay, I need to create different calculators. Oh, sorry, CX, oh, okay, my mistake. Put here, CY, put it here. As you can see with your pipeline, just connect function, filter, source, so there is no limitation there. And now here you have your coordinates. Okay, so that corresponds to the cell center, so to the node, sorry, in the mesh. And let me add another one, and for instance, you want Cmag, the magnitude, then, okay, so for instance, school C vector. Okay, so you can assemble a vector, so you get this one coordinates times I hat mass plus j hat plus, and we assemble a vector, and times k hat apply, and there you go. And now you have X, Y, Z, and the magnitude computed automatically, or you can, or if you want, you can create the calculator and then compute the magnitude. To point out regarding this one, that there are some filters that they do require a scalar. So for instance, if you have this vector, it won't work. Okay, even if you can access the component here, it has to be, you know, a plain scalar like in this one. Okay, so Cx has to be a scalar. It cannot be part of a vector. So be careful about that. There are a few filters. Probably we're going to encounter one of those in the sense that we're doing. So yeah, at this point, this CC, what else can we do here? So we have place cell centers. These filters very important. So let me go here and apply one. And by the way, all this stuff we're doing in the domain, but you can do it also in the aircraft. There is no limitation whatsoever. So let me go and let me put here, and no, so I can go like this, or point out. Okay, yes, so this one is giving me the coordinates. So what I wanted to do is give me CY, and probably can apply this, and you have orientation. Okay, no orientation, no scale, and all points. We have everything, and I want spheres, and I want something much smaller, and I go here, much smaller. Okay, and let me put this here. So basically you see that we are plotting now the nodes, now how their elements are connected. So probably would be better here, put it there, and that's it. Okay, so if you want to do a nice plotting, you can get it there. So now a new filter, we introduce this one, it's called Glyph. You use it for vectors, but yeah, Glyph is more general, so you can put it spheres and so on, and you have seen that you have many options. So later we're going to play a little bit more with this one, now to do projections and so on, but there you go. Look at that, how we're getting now more complex and nicer visualizations, and super easy to use. So thank you, and see you in the next video. Bye.